Hi everyone, today's subject is creating a parabola. As you know, a parabola has an equation which is quadratic, which is a quadratic equation. And you may simply write x squared plus 2x, for example, plus 2 in the input bar and push the enter button, and you can simply obtain a parabola. And you can even drag it, and while you're dragging the parabola, you can also observe the change in the equation in the algebra window of GeoGebra. But even you can create a better exploration by using sliders, which I mentioned in the 8th video of simple and efficient dynamics exploration. But in this video, I will show you a different approach. I'm deleting the parabola. As you know, a parabola is defined as, let me create a line before and a point. This is my line and this is the point. A parabola is defined as the locus of the points which has same distance to a constant point and a constant line, like this, approximately this kind of the set of points. The distance to a constant point and the constant line is same in all point of this curve. The set of these points, the set of the points creates the curve. We call the parabola as this in Euclidean geometry. And while using this definition, I will create the parabola, and I am again deleting my points. Let's make our preparations now. I will use sliders to make a generalization after creating the parabola, which is A, B, and K. I will show you the role of the sliders now. My sliders will work as a point AB. This is my focus point, and the line y equal to k. Why I choose a line, a horizontal line? Because the parabolas whose directrix is horizontal are elementary parabolas. Of course, you can choose any line, but in that time your parabola is a bit confusing. This is a subject of another video. Now I will create the parabola whose focus point is AB and whose directrix is y is equal to k, a horizontal line. This directrix is the line which the point of parabolas same distance to the line and to the point. The point is focus. Now I am ready to create the parabola. Let me change the directrix style, not to confuse my actual curve. And where will be our points which creates the parabola? Just put a point on the directrix and create a perpendicular line passing through this point and perpendicular to our directrix. Why I created this perpendicular line? Because my candidate point which create the parabola will be here somewhere on this line, because the distance is perpendicular distance, and my point will be somewhere here. This distance and this distance must be same, and I need to create a, please imagine an imaginary point here. There is a triangle here, and this triangle must be isosceles triangle. So create a segment between A and B and find its midpoint. My imaginary isosceles triangle is here, and create its height. Then find the intersection point of these two lines. So your imaginary triangle, which is isosceles, is here. The distance AD and DB are same. You can also measure it to be sure. As you see. And when you move to point B, the distances are every time similar for every place of B. So you have a point whose distance to the line y is equal to k, and the distance to A are same. The locus of this point is parabola, and you need simply to open the trace of this point, then move the point B, and this trace is parabola. This trace is parabola. Okay. Just clear the traces and move the point A somewhere different, and the directrix in again somewhere different, then obtain a new parabola. Okay, just we don't have the equation of this parabola. The second phase of our work is obtaining the equation of this curve, this locus. At that time, we will use our parameters, which are created as sliders previously. This is a task for you. Just try to write the equation of the point whose distance to the ordered pair AB and the line y is equal to k are same, and this equation will be in terms of AB and k, and just simply write that equation into input bar. You will see that the curve and this trace are same. Thank you very much to watch me.